Hello class, I'm here to talk about the last video for tonight. I did just finish problem 76 and then I realized I did not assign 76. However, it's a great thing after all because the problem 76 is talking about a two-tail for a normal distribution, and I showed you how different it is when calculating your significance level, or actually your p-value, that instead of dividing you're multiplying by 2 because you're looking for, actually I have put it down here. See, you're looking for right here you have defined a z-score would be of minus 0.866. However, it's a two-tail, so you're really looking for all the values below 0.866 and above 0.866. Therefore, and it changed the confidence level. So it was a good thing that I showed problem 76. Let's go to problem 78, which I can tell you right away is also a two-tail. And let's read the problem, and you're going to notice quite a few differences. That's why I want to go over 78. It says the mean number of sick days an employee in general takes per year is believed to be about 10. The mean number, so we're working with the mean, correct? Not proportional of sick days an employee takes per year is believed to be about 10. So in general, we're talking about employees taking sick days, and he believes to be about 10. So say equals to 10, and I just said that we are working with the mean, correct? Not a proportion, not a percentage, and it says to be 10. You know what? Let me put the mean over here because then I can refer to the values for the formulas. So you're saying that your mean is equals to 10. Therefore, if your mean is equals to null hypothesis is equals to 10, sorry about that, then your alternative hypothesis has to be different than, correct? If you refer over here. Okay. Then we keep reading. They randomly survey 8 employees. They randomly survey 8 employees. The number of sick days they took, the 8 employees, for the past year are as follows. I put it over here and you're going to understand why. 12, 4, we're talking about days, 15, 3, 11, 8, 6, and 8. So they survey 8 employees, and this is what they got. Well, we need to average these days to see what is the average of 6 days they took. So we can do average. You can either do average. Actually, we can put it up here because that's going to be the mean of sick days for these 8 employees. So let's go over here. You know what? Instead of putting the formula, not everybody's comfortable with Excel. 12 plus 4 plus 15 plus 3 plus 11 plus 8 plus 6 plus 8. And then you're dividing by 8 employees, correct? You found a mean for the sample they took of 8.375 days, which really you could use that value if you would break into fractions, multiply by the days, and do like 3.5 days or 2 point, I don't know, 4 days. Not necessarily um, accurate, but you could have broken numbers, not whole numbers. Okay, and then let x be the number of sick days they took for the number of sick days an employee um, took for the past year. Should it be should the personnel team believe that the mean number is 10? So they're asking, should they believe that the mean number is 10 based on all this? Well, if you notice here, we're missing quite a few information, correct? First of all, super important. If you're not giving an alpha for a problem, you use 5% always. So you're right here, your significance level is going to be at 5%. use alpha as 5%. You're not giving the standard deviation for the population, neither the standard deviation for the sample. Well, we can go ahead and calculate the standard deviation for the sample based on these numbers, correct? But not for the population. Therefore, if you have a unknown standard deviation, you're gonna be using the t distribution, or you can call it, they call the student t distribution. Right here, you already define where it's gonna be. Right here, state the distribution to use for the test. Here you go. I can even see, so I'm gonna replace it right here. Okay. I should put that volume so you don't have to listen to that. Let's see if that helps. Okay. So we have stated, let's go ahead and calculate the standard deviation of the sample. The easiest way for you to do it, so you don't have to go through everything, is just to do equals to the standard deviation of the sample, okay? Because you're just doing the 8 employees right here. So it's going to be about 4.10 days. Therefore, your null hypothesis you have previously stated, correct? Let's just put it like this. So your alternative hypothesis you have stated to be the mean is different than 10. In words, and let me state what is my random variable. We're working with x bar, not proportions. Therefore, let my x bar is equals to the mean number of sick days an employee takes per year. I know I'm going a little fast, is because I've done this before. We're just now using the t-test instead of the z-test, and I don't want to have a long video, so you can actually watch it all the way to the end. We have already answered what distribution. We're going to use a t-distribution. Therefore, I have put it here how you're going to calculate your test statistic. Just remember, you calculate your t distribution differently. You're gonna subtract 1 from your sample size to get your degrees of freedom. So your degrees of freedom is gonna be 8 minus 1. So you're actually gonna be looking for a number of 7, and on degrees of freedom, you're going to be using a 7, and for your alpha, you're going to use a 5%, and this is a two-tailed test. Okay, so your T statistics. So let's go ahead and fill out the numbers. My X bar, 8.375 minus my mean divided by my standard. See right here, it is symbol change. This is the standard deviation for my sample size, which I was able to estimate, but let me put it between parentheses so it doesn't give me any errors. Divided by the square root then of my full sample size. You should, sorry about that, you should find a value of, there we go, minus 1.12. Just keep in mind that we are searching for a value 1.12 each side, which right here I have actually put a graph for you together. Let me see if I can select this. Okay, so we are looking for all the values, possible values below 1.12 and above 1.12 is a two-tail test. How do you define that? Open your T table, okay, and then let's go right here and see that again we have a degrees of freedom 7, correct? We have a degrees of freedom 7 right here. Let me make bigger, see if I can do that without. Mm, okay. Yeah, that's good enough. So you have a degree of freedom of 7, correct? And you're looking for a value that is about minus, actually 1.12, because you're looking for both sides right here. This is the closest you have to 1.12, 1.119. So that should be sufficient. Well, now what you need to do is to go up here and determine you're working with a two-tailed test. You're working with a two-tailed test, correct? Therefore, you're going to have a p-value of 0.30. 0.30. Again, you're working with a two-tail, therefore, you're going to be using 0.30. If you're using a one-tail, you would be using the 0.15. Therefore, we know that right here, my p-value, it's going to be equals to 0.30, correct? I just, we need to repeat it. Here we go. Degrees of freedom 7, because your sample size 8 minus 1. You're working with the two tails and you have found a t-score. Your t-test statistic is 1.12, or you could say this is the closest, therefore go up. For a two-tail, that's 0.30, because you're not looking for the one tail, you're looking for two tails. Here we go. So it's a 0.30. Then right now, to complete the problem, well, let me see one thing here. Your alpha, remember what I said, if you're not giving an alpha, let's use 0.05. Therefore, well, your alpha is 0.05. It's 0.30 smaller or higher than. Smaller or higher than. Your, it's smaller than your p-value, correct? Therefore, your decision is do not reject. Do not reject. The null hypothesis. The reason for decision, I can move this over here. It's because the p-value is greater than the alpha. In your conclusion, well, at the 5% significance level, there is insufficient evidence to conclude that the mean number of sick days is not 10. You're rejecting, again, you're rejecting the null hypothesis. Therefore, you're concluding that the mean number of sick days is not 10. Lastly, let's build our confidence interval. We're actually going to do a little different, because you have determined the alpha to be 5%, correct? And you also have determined the degrees of freedom to be 7. So let's go back to the t-table. So if we now look for degrees of freedom 7 with the alpha for a two-tail, correct? A two-tail now, correct? We're doing the other way around now. For a 5%, again, if you have a degree of freedom of 7 with the 5%, you actually have a confidence level or a value of 2.365. So here, instead of using this table, we're going to be more precise, and we're going to put a 2.365 times my standard deviation, that was 4.10, divide my square root of my sample size. To find the lower bound, you're gonna do the 8 point, I gotta do equals 8.375 minus my error bound margin. Find my upper bound. We're gonna do equals to my 8.375, which is my true mean, plus this value. And now we can see then the confidence interval for the um, t-value 7 degrees of freedom at 5% is actually a 4.947. So you're gonna put you can put 4 point, yeah, you can put it with 3 digits, it's fine. And then 11, so it's uh, between a little lower 5 days and then a little high in almost 12 days.